Good morning, children. Let us continue with exercise 5.3 derivatives of implicit functions. Now this time we are going to do with inverse. Okay, inverse also. Implicit functions with inverse. Okay. So here, children, such kind of problems when it comes, children, mainly the substitution method will work. How do I guess it is substitution method? Because if you look at the bracket term, children, it will remind you of some formula. How? Suppose if I look carefully at it, children, it looks like 3 tan theta minus tan 3 tan theta minus tan cube theta. It's not x cube, okay, minus tan cube theta upon 1 minus 3 tan square theta, which is nothing but the formula for tan 3 theta. So what my guess is correct, right? So what I'm going to do, put x equal to tan theta. If x is tan theta, then you know that, children, the range of theta should be between minus pi by 2 to pi by 2. This is by the definition of tan function. For us, it is given that minus 1 by root 3 is less than x is less than 1 by root 3. So instead of x, I am going to put here tan theta. Okay. Now you know that, children, right? You know that tan 60 is 1 by root 3. Yes or no? Yes or no? Yes. So it means your angle will form, and similarly you have tan of minus 30, tan of minus 30 as tan of minus 30 as minus 1 by root 3. Because tan of x is same as tan of minus x. You have studied this formula. Tan of x is now, so I will substitute here as, this is tan theta, right? So here it will be, theta's value will be between this. Do you understand? Because for theta equal to minus 30 degree also, tan theta is minus 1 by root 3. Tan of sine, you know that sine of minus x is, sine is an odd function. Sine of minus x is minus sine of x. Cos of minus x is same as cos of x, but tan of minus x is same as minus tan of x. Okay, so that's why your theta will write between minus pi by 6 and pi by 6. But we want the formula for 3 theta. Yes, so I'm going to multiply this by 3. So this is going to be 3 pi by 6 less than 3 theta less than 3 pi by 6. So this will be minus pi by 2 less than 3 theta less than pi by 2. See, children, why am I doing this is because, children, when I write in the next step y equal to tan inverse of, I'll put the substitution now. So it will become 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Okay. So in this step, what will happen? In the next step, when I write tan 3 theta's formula, the next step will be cancelling of tan inverse and tan, because I did so many adjustments to get rid of my inverse trigonometric function. So at that time I have to make sure that my tan inverse, if it want to get cancelled with tan, I have to make sure that the tan inverse will fall between the range of, you know that the range of tan inverse is nothing but between minus open interval minus pi by 2 to pi by 2, which is true here. So I can cancel this and can write here 3 theta. So I have guaranteed here the existence of theta, tan 3 thetas, so that the value will be in the range. That means it will be well defined. So this is nothing but 3 theta. 3 theta. Theta is but our tan inverse of x, because x is tan theta. So now you can apply derivative. So dy by dx will be 3 times of tan inverse of x, derivative is 1 upon 1 plus x square. So this is your derivative of this complicated function. Alright. Same way, let us do the second one. Second one also, just have a glance at it. If you look at it, children, it is of the type, you have studied your trigonometric formula. It is 1 minus tan square theta upon 1 plus tan square theta, which is nothing but the formula for cos 2 theta. Okay, so we have to apply that. So what I will put here, 1 minus tan square theta I want here. So I will put here x as tan theta. Again, you know that the range of theta is between minus pi by 2 to pi by 2. In this it is existing. Yeah. So now, but given for us it is 0 less than x less than 1. So it is 0 less than tan theta less than 1. Now you know that for this tan theta between 0 to 1, your theta has to lie between 0 and pi by 4, because you know that, just look at the extreme points. Okay, forget about inside. Tan of which angle is 1? Pi by 4. Tan of which angle is 0? Tan 0. Similarly here, tan of which angle is 1 by root 3? It is 30 degree. Okay, the same thing is on this side also. Okay, but we are interested in, I said it is a formula for cos 2 theta. So it will be 0 less than 2 theta multiplied by 2 pi by 4. 2 times. So 2 and 4 will get cancelled and you will get pi by 2. And you know that it is in the range. Okay, it is in the range. Okay, how do I check it is in the range? Again, let us simplify this. So this will be y equal to, when you do such things, no, you will be guaranteed that your angle will follow in the range. Okay, so this will be sine inverse of 1 minus tan square theta upon 1 plus tan square theta. So this is sine inverse of cos 2 theta. But children, I can't cancel sine inverse and cos. So I am going to write it as, you know that sine of pi by 2 minus theta is cos theta, right? So I have written this. Okay, now sine inverse and sine can be cancelled, because your range of sine inverse is nothing but closed interval minus pi by 2 to pi by 2. Yeah, closed interval minus pi by 2 to pi by 2 means 0 to pi by 2 will fall inside that. So you are free to cancel this. Okay, so every step, whatever you have to do, you have to guarantee the assurance that it is existing. Okay, so this is y equal to pi by 2 minus 2 theta. That means y equal to pi by 2 minus tan inverse of x. Now again apply differentiation. So this will be 0 minus 2 times tan inverse of x's derivative is 1 plus x square. So answer is minus 2 upon 1 plus x square. Always in such problems, children, you make sure the definition, okay, that it exists. Now let's go for third one. Okay, now this is not an obvious a formula, right? We are not seeing such formula. So here let us do something such that this sec inverse, and here also sec comes and you can cancel it. Okay, so if I put here x as cos theta. Okay, if x is cos theta, you know that for its existence your theta should be between 0 and pi. Your value of theta, your domain should be between 0 and pi, closed interval 0 pi. This we have already seen in the lesson number 2. But given it is 0 less than x less than 1 by root 2. Yeah. So 0 less than cos theta less than 1 by root 2. Cos of which angle is 1 by root 2, children? 45. Yes. So this is going to be, your theta is going to be 4. Okay, this side I can write 0 because it is less, no? So no problem. Now we have to check this. So y equal to sec inverse of 1 upon 2 cos square theta minus 1. So this is sec inverse of 1 upon cos 2 theta's formula. So this is nothing but sec inverse of sec 2 theta. Now can I cancel sec inverse and sec? Yes, I have to cancel sec inverse and sec because my 2 theta I want, no? So let us check here. 2 theta means 0 less than 2 theta less than pi by 2. Now this is a well-defined range. I can cancel because the range of sec inverse is closed interval 0 to pi minus pi by 2. Closed interval 0 to 2 pi minus pi by 2, and pi by 2 is already not here. So I can cancel. So this will become 2 theta. So this is y is equal to 2 times cos inverse of x. And you know that if I take differentiation, this will be equal to minus 2 upon square root of 1 minus x square. Okay. Now here if you can see I have written here 0. Why, children? Because I know that, children, cos of 0 is 1. Yes, and 0 is 1 means it is greater than 1. So there is no harm in writing here 0. Okay. Because cos 0 is 1, and 1 will always come inside this range of 0 less than 1 by. So this is our answer. Or moreover, you can see that because your right side is 0, left side is 0, you can also copy it as 0, no problem in that. We have to write this side, or we are more concerned about this side. Okay. Now the next one, y is equal to sine inverse of 2x into square root of 1 minus x square, where your value of x is between minus 1 by root 2, x less than 1 by root 2. Here also there is no direct formula, children, here, but if I am able to write sine and sine inverse and sine here, then that will get cancelled. Okay, so let's try. Put x as, see, you have to do trial and error method. Okay, sine, see, it is sine inverse, no, so sine should be there, so you have to think in that way, what value of I will put here, so I will get here. So here, if you see here properly, children, it is of the type 2 sine theta cos theta. Yeah, only that formula we know. So I am trying to cook here sine 2 theta. Okay, so x is sine theta, and you know theta for sine is nothing but between minus pi by 2 to, that means closed interval minus pi by 2 to pi by 2, but it is minus 1 by root 2 less than x is less than 1 by root 2. So this is minus 1 by root 2 less than sine theta less than 1 by root 2. Now what value of theta is theta is 1 by root 2, pi by 4. So this side also I can write here minus pi by 4, because sine is an odd function. So, but we want sine 2 theta, so multiply by 2. So your theta will be, 2 theta will be in this range. Okay, now let us see whether we can cancel in this range or not. So now your function will be y equal to sine inverse of 2 sine theta. Now 1 minus sine square theta. So this will be equal to sine inverse of 2 sine theta cos theta. Because 1 minus sine square theta is cos square theta, its root is this. So this is sine inverse of sine 2 theta. And I told you sines, sine inverse and sine can be cancelled, because it is the range of sine inverse is nothing but closed interval minus pi by 2 to pi by 2. So this is sine inverse will get cancelled, so it will be 2 theta. So it is 2 times sine inverse of x. So this is derivative will be of 1 minus x square. Okay, so that's all for today. We have completed with exercise 5.3.